Hello students, welcome again. In today's video, we will discuss the basic difference between dB, dBm and dBmicro. dB, as you all know, is a technical term defined to describe the power gain or voltage gain of a given system and its full form is decibel. Okay, when we are studying the communication system, specifically satellite communication and optical communication, the received power is very low in the range of milliwatt and microwatt. In that cases, we will also find the technical terms dBm and dBmicro. What does these terms mean here and how we can interconvert a given value in dBm directly in dB or dBmicro will be explained in this lecture. And after the detailed explanation of all these terms, we will solve some numerical problems that has been selected from previous engineering services pre-examination. Okay, so dB, as you know, is a short form of decibel. Okay, and it is used to define the power gain or voltage gain of given system. Let us consider you are having your system that is input voltage V in or input power P in, and at the output you received output voltage V out and you measure the power as P out. Okay, then power gain is defined as P out divided by P input. Okay, this will be absolute number because both the quantity have the same unit, as well as voltage gain is V output divided by V input. In cascaded system, when this output will be used as the input of the next system and the output of this system will be used in the next system, we generally define this power gain and voltage gain in dB. Okay, so if you have to define power gain in dB, you will convert this ratio in log of 10. Okay, and this is the term or definition of power gain in dB. 10 log of 10 P output divided by P input. As the P power is nothing but V square by 2R. Generalized discussion is V square by 2R. So, if this ratio is defined in the terms of voltage, then voltage gain in dB is P is proportional to V square. So, if you put V output square here, this square will make it 20 log of 10 V output divided by V input. These are the very basic definitions that you have studied many times for the years when you are studying basic mathematics or basic engineering. Okay, in the case of communication, you are also finding the power level description in the form of, you will also find dB watt or dBm watt. Okay, so what does these terms mean and what does conclusion you can find out with the given parameters is explained in this video. Okay, so when you are comparing your output power with respect to input power in watts, okay, let me write it capital W so there is no confusion between omega and watt. With respect to watt, if you measure P output with respect to P input in watt, you will define your gain in dB. Okay, P output when P input is 1 watt, output is or gain is defined as in dB. Okay, in next step, when you are defining or calculating or measuring your output power with respect to the input power treated as 1 milliwatt, if you consider that this system is fed with 1 milliwatt and you are getting P output, how many times your P output has increased when input power is 1 milliwatt. This particular gain will be defined in dBm. This is a power unit representation with respect to 1 milliwatt. It means how much times your output power is with respect to 1 milliwatt. Okay, if the base power is 1 milliwatt, then how much times your power is larger than 1 milliwatt will define your gain in dBm. In dBm, you are defining your gain when input power is 1 milliwatt. This is a basic difference, nothing very important when P input is 1 milliwatt. Very simple. Similarly, there is one another term dBmicro. When input power is 1 microwatt, how much output you are getting will be defined as power gain in dBmicro. Okay, these three are units to define your power gain. When your power is in the range of watt or kilowatt, you can go for dB. Okay, power gain can be represented in the form of dB. But when our received power, in the case of satellite communication, when the travel distance is very large in the thousands of kilometers, you are receiving power in the range of microwatts. So you will represent your gain in dBmicro. Okay, you will take the reference input voltage, input power 1 microwatt. You will treat your system that if we feed 1 microwatt input power to the system, how much output we will get at the output terminals. Okay, when reference is 1 milliwatt, your power gain will be in dBm. When reference is 1 microwatt, your power gain will be defined in 1 dBmicro. So these are nothing but three different presentation of power gain when input power, when reference input power is of different level. Okay, so I think this is very clear to you. Here we are describing dB as a gain. Okay, you are having two quantities, power input, power output, and you are defining your gain in the form of dBs. In communication systems, our radiated power, our transmitted power also defined in the form of dB watt. Okay, this term describes how much your power is having intensity higher than the 1 watt. Okay, so dBW is nothing but power level intensity with respect to 1 watt. Okay, okay. So dBW is again, in this case we are not discussing the power gain, or we are not discussing any concept of gain. Simply our power level is compared with different reference levels. If you are comparing your power level with respect to watt, then you will define it dB watt. Okay, your power in watt and you are comparing it with 1 watt. Okay, similarly dBmW, this term you will also find in your literature in your numerical problems. If they are asking what is the value of dBmW, they are simply asking power in dBm. So it means your power is in the range of milliwatts and how much times it is greater than 1 milliwatt. Okay, so power intensity with respect to 1 milliwatt power as a reference. Okay, and similarly dB microwatt, this is term to describe the power intensity when reference power is 1 microwatt. These terms are used in satellite and optical communication. I will explain these terms with help of an example. For example, you are having a power of 2 watt. Okay, if the numerical asks for this power in dB watt. Okay, this is a general unit. You describe your power at the input or output. But in communication you will also find a unit dB watt. Okay, if they are asking to dB watt, this will be 10 log of 10 2 watt with reference to 1 watt. In dB watt we will have a reference reference power of 1 watt. So this is 10 log of 10 to, this is almost 0.3. So you are having 3 dB watt. Okay, your 2 watt can be represented in the form of dB watt as 3 dB watt. Okay, if the next problem asks for represent this 2 watt power in dBm, okay, then write the same formula, 10 log of 10 2 watt, the reference power is 1 milliwatt. In dBm we will compare our power intensity with respect to 1 milliwatt. Okay, so convert this 2 watt in milliwatt, so you can find the absolute number, 10 log of 10 2000 milliwatt divided by 1 milliwatt. Okay, so this will be 2000, 10 log of 10 2000, this will be 10 log of 10 2 plus 10 log of 10,000. This will give you 33 dBm. Okay. In next step, they can ask for a conversion of 2 watt in dBmicro. Same procedure you will adopt for conversion in dBmicro. 10 log of 10 2 watt divided by 1 microwatt, and this will give you 63 dBmicro. Okay. So you can find when you are comparing your power intensity with respect to 1 watt, you are getting dBW. When you are comparing with 1 milliwatt, you are getting dBm. When you are comparing with 1 microwatt, you are getting dBmicro. Okay. So with these results, you can finally write down a direct conversion formula. dBm is dBm in watt. Okay, when we are describing in communication, we are describing our power in the with the unit of dBm, dB or dBW. And when a numerical problem handles the terms dBm or dB, how you can directly convert. Okay, dBm watt will be dB plus 30. Okay, you can find it out. When you are comparing your level with 1 milliwatt, your level will be increased. Okay, similarly dB microwatt, write down dB watt plus 30. dB microwatt will be dB watt plus 60. Okay, this is a very important formula that can be used for a time saving trick for your numericals that you will face in your exams. Okay, and if you are describing all these formulas in volt, then dB millivolt will be dB volt. If you are not describing power gain, you are describing voltage gain, then you can write down 60 dB microvolt is dB in volt plus 120. Okay, as power is proportional to V square, we have described that voltage gain is 20 log of 10. For the better understanding how the numerical problem will be formed and you have to solve this, we will have some example of previous years engineering service examination. These problems are selected from last year's question paper. The first question says 13 dBm is equivalent to, and you have to represent. Okay, power equals to 13 dBm. Okay, so you can write down 10 log of 10, let your power is x, equals to 13 dBm. So x is 10 raised to power 1.3. X is, here the unit is dBm. So result will be calculated in milliwatt. X will be 20 milliwatt. Okay, very simple. This is in second problem. It says during a power measurement, the output power measured was minus 90 dBm. What is the power in watt? Okay, So students get confused that power is coming with a sign of minus. Is it possible that power is having a minus sign, or power gain is coming with the minus sign? If you are given a parameter that power gain is minus, or your power is minus 2 dB, how this is possible? How power can be with a minus sign? This is possible with the dB, dBm or dBmicro. This sign simply says when unit is dB and there is a minus sign, that says your power is lesser than 1 watt. Your reference power is 1 watt and this minus sign says your power is lesser than with 1 watt. Minus 3 dBm says your power is lesser than 1 milliwatt. Okay. x1, x2, 10 log of 10. Okay. When x1 is less than x2, there will be a minus sign in logarithmic conversion. So this minus sign is saying our power intensity is lower than the reference intensity. So this minus sign is possible when you are representing your power in minus. So minus 90 dB. Power is minus 90 dBm. With this given formula you can find out minus 90 dB means power in milliwatt can be converted as 10 log of 10 x by 1 milliwatt, that is given minus 90. So x is 10 raised to power minus 9 milliwatt. Okay, 10 raised to power minus 9. So x is 10 raised to power minus 9 milliwatt or 10 raised to power minus 12 watt. Milliwatt, simply convert milliwatt in watt. So you are getting 10 raised to power minus 12 watt. So your answer will be 1 picowatt. So this will be the correct answer. In the last one, 20 milliwatt was the correct answer. In this third example, you will find the example of interconversion of watt, dB and dBm. Okay, an earth station launches 1 kilowatt high power with an antenna that has gain of 65 dB and connector loss of 1 dBm. What is the effective radiated power in free space? And all the options are given in dBm. So we have to convert all the given units in dBm. And what does this problem says? It states that 1 kilowatt input power is amplified with an antenna that has a gain of 65 dB. Okay. So here the input power is given in kilowatts and antenna gain is given in dB. If there was no loss, then total radiated power P output will be P input multiplied by gain. Okay. So P output in dB will be power input in dB plus gain in dB. Okay. When there is multiplication in numerical value, there will be addition in logarithmic value. So power output in dB will be power input in dB. Your input power is given in kilowatt. How much? 1 kilowatt will be in dB? In dB, okay, dB watt. P input in dB watt will be 1 kilowatt, 10 log of 10, 1 kilowatt compared to 1 watt. Okay, so this input power will be 10 raised to power 3, 30 dB. Okay, so 30 dB input power is added on with 60 dB gain and total output power will be 60 dB plus 65 dB. You are having a total radiated power of 95 dB. Okay, if there was no loss, you will have a power radiated in free space 95 dB. But there is a loss of 1 dBm. Okay, that connects this antenna to the free space. Your loss is mentioned in dBm, your power is mentioned in dB and options are in dBm. So convert this radiated power in dB. We have studied dBm is dB plus 30. Simply add 30 to the value given in dB and you will get the value in dBm. So 95 dB will be equal to 95 plus 30, that is 125 dBm. If there were no loss, you will have this much radiated power, but there is a loss of 1 dBm. So radiated P radiated will be 125 dBm minus 1 dBm loss, that is connection loss or connectant loss to the medium, 1 dBm, that is 124 dBm. So your correct answer will be option D. With these few examples, I hope the concept of dB and dBm is very clear to you. In numerical examples that you are going to face in your exam, there is a frequently variety of problems that are based on dB and dBm. Once you have studied the concept thoroughly, you can directly convert given the units and you can have a time saving trick in your numerical approach. I hope this concept is very clear to you. You can apply this approach in your communication engineering when we are solving your numerical problems. Keep learning, keep watching. Thank you.